once again to my channel. This is your man Alam, and today we are looking at another subject matter in mensuration. And so I have a question on my board that we are going to deal with. But please, if this is your first time of joining my channel, please do me a favor by subscribing, like and share to bless other people and us again to support my channel. Thank you, and let's dive into the video. So this is a very nice question under mensuration on the circle properties. So a chord AB of length 8 centimeters, right, is drawn in a circle of radius 7.8 centimeters. So you measure 7.8 centimeters, you draw a circle. That is where the chord was drawn. Find correct 2 decimal place. I, the angle the chord subtends at the center. The length of the minor arc. Then you also find the area of the major sector, the triangle AB, its area, and the area of the major sector formed by the chord. Now you can take a screenshot of this because the board may be full and we have to clean it off so that we can solve the solution on there. So let's get into it. Now, because of the length of the video, I have drawn a circle here. They are saying that the chord drawn, chord AB, is 8 centimeters. And the radius, which here is the center, to B and A is the radius of 7.8 centimeters. Okay, so this area from A to B is the minor sector. Okay, so if I have this is the minor sector, A, O, B. This whole area is the minor sector, and the above is the major sector. So if I'm tracing from A to B, is the major sector, but from A to B from this side is the minor sector. So the minor sector is the smaller part, and the major sector is the bigger part. So when we are mentioning the major and the minor sector, you will know what we are talking about. All right? So the first part of the question says that we to find the angle the chord subtends at the center. This is the chord AB, and it subtends at the center. So we are looking for the angle here, say X. We are looking for that particular angle, which we denote by what? X. Okay? Now, if I draw this angle, triangle out, that is what I have drawn over here. So, OA and then OB is the radius, so which means here is 7.8 centimeters. And then AB is 8 centimeters. From A to B is 8 centimeters. And I'm bisecting this, because this is a radius and this is also a radius, it means this is an isosceles triangle. 2 of the sides are equal and 2 baselines, so the angles must also be what? Equal. So once I divide this into 2 and it's an isosceles triangle, it postulates that this angle here, so we say alpha is equal to the angle here, alpha. Alright? So which means this line to this and this have also been divided into 2 equal parts, and this forms an angle of 90 degrees. Okay, because it's bisected into 2 equal parts. So if it is 8 centimeters from A to B, here is 8 centimeters. So it means from A to C is 4 centimeters, and C to B is also 4 centimeters. All right. So this is the information that we have drawn out from the question. Now we are going to calculate for this angle, the alpha over here. And when we put the alpha together, we get the value of what? X. So take note of that. Now, which property can we apply? We can apply the Pythagoras theorem property, because we have a 90-degree angle being formed here. And once we get the 90-degree angle, we can apply the Pythagoras theorem property, which we can know the shortcut, which is SOHCAHTOA. Sine opposite hypotenuse, cosine adjacent, tan opposite over adjacent. So we look at here which of the sides are given to us. We know here the hypotenuse, and we know this side too, this angle here too. So this line, we know this and we know that. So if I want to find the angle which is at the top, I can use opposite over hypotenuse, because I don't know here. So I would have taken opposite over adjacent, but I don't know this angle unless you find it using the Pythagoras theorem. So you could have find this side OC before you go ahead. But once I have two sides, I don't have to come and find this. I can just use which of the properties here. I know opposite and I know the hypotenuse, so I can use sine. Okay? So I can use sine. So the angle, that's sine of the angle, is equal to line CB. You can also use AC over OB. And OB is the hypotenuse and CB is the opposite. So this is equal to CB is 4 centimeters over OB, which is 7.8 centimeters. All right. This centimeters is going to go with this centimeters. And you break this down. So I now have sine of alpha is equal to, so you can use your calculator and key inside. So that's 4 over 7.8. 4 over 7.8. And that will give me 0.5128. Now I take sine inverse of both sides. So once I take sine inverse of this side, the sine goes, leaving alpha is equal to sine inverse of 0.5128. Okay? And this is equal to, take sine inverse. So we press shift and the sine symbol. They now type the value inside, 0.5128. So it means my angle is 30.85 degree. Now remember, this is one side of the angle, but there are two, so I can add them to get x. X is equal to 2 times of alpha. These two of them will give me the whole of this. So this is equal to 2 times alpha, which is 30.85 degree. And this is going to be equal to, you multiply this by 2, and I'm going to get 61.7010 degree. Now the question, the preamble is saying that find correct 2 decimal places. So once they have given us the decimal place to correct you, so you have to do that. So you draw your conclusion. So therefore, the angle the chord subtends at the center. So this conclusion is very important. The angle the chord subtends at the center is 61.70 to 2 decimal places. So the one here, the value after the 0 is not up to 5, so we can't round it to the 1, so it's 0 to make 1. So we just write 61.70 degree. 2 decimal places. So that is how you deal with the first part of the question, the I. Now when you look at the II state that we should find correct 2 decimal places, the length of the minor arc. The length of the minor arc. So they are looking for from this place, the length here. They are looking for the length here. That's the minor arc. Remember, the length of the major arc will be at the bigger side. So that's what we are going to deal with. Alright, so I. So this first one we dealt with was the I. So this is the I. The length of the minor arc AB. The length of the minor arc AB is given as, so you can just quote it. So we have arc AB to be equal to 2 pi r, then the angle over 360 degrees. So the angle there is x. I'm using x for the angle. That is this angle. So you pick 2 pi r. 2 pi r is the circumference of the whole thing. So the length of the complete circle is the 2 pi r. But you are screening it to the angle alone. So from this side. So you pick the angle over 360. And 360 is the degree for the entire circle. The complete circle makes 360 degrees. But we are picking only this side out of it. And so this is going to be equal to 2 times 22 over 7 times the r. R in the question is 7.8 centimeters times the angle, which we have found to be what? 61.70, all on 360 degrees. Now that we have this, we can use our calculator to simplify it. So get the calculator. So this is equal to 22 over 7. Now remember, if the 22 over 7 is given to you, that is the pi, is given to you, sometimes given to you as 3.14 and all that. If it's given to you, you are going to use it. If it's not given to you, you just quote it as 22 over 7. That is the full one. So this is equal to, you type 2 times 22 over 7 times 7.8 times 61.70, all on 360 degrees. And your answer is going to be 8.4029 centimeters. Remember, we have only 1 centimeter there, which is this one, and it's still affecting me. Now, this is the length of this arc, but the question is saying that we should correct it to 2 decimal places. So you have to correct it to 2 decimal places with your conclusion. So therefore, the length of the minor arc is 8.4029 decimal place. Alright, 2 decimal place. Remember to put the centimeters. So these are the small things that takes you off when you don't put the unit. Okay, so that is how we find the length of the minor arc. Now we go to the II. The II, that's the third one, is asking us to find the area of a major sector. The area of the major sector. We are looking for the area of this place, the major sector. Then we are looking for the area of the triangle, AOB, this triangle, and also the major sector formed by the chord. So now the last one is talking about from A to B upwards. So the AOB is not part again. So we are now extending the major arc to this place. Alright? So from the whole of this, including here, is the major arc formed by the chord. So that's what we are looking for. Alright? And so there are 2 ways you can deal with that one. So with that, let's continue. Please, if this is your first time of joining my channel, please give me a subscribe and a like so that YouTube can promote my videos to a lot of audience. In that way, you are helping to grow my channel. Alright, so let's dive into the area of the major sector is, that's I, A. The area of the major sector is, the major sector AOB is equal to, so we can illustrate that one too by an angle. So we can say theta over 360 degrees times the area of the whole circle. So the area of a circle is pi r squared, and we are looking for just the top alone. That's the bigger side. Now this theta can be found. So theta is equal to 360 degrees minus the angle x. So 360 degrees minus x. X we found was 61 point something. So let me get it from here. 61.70 degrees. And this is going to be equal to 298.297. You can use the calculator to point it out for yourself. Now that we know the theta, we can just substitute inside to find that particular area. So this is going to be equal to 298.297 all on 360 degrees times 22/7 times 7.8 squared. Alright, 7.8 squared, that is the radius, and this is being equated to, so you can use the calculator, punch inside, and your answer will be there for you. So I have my answer as 158.4383 centimeters squared. Because an area, we are using the unit as what? Centimeters squared. But the question, the preamble is saying that we should round it to 2 decimal places. So I'm going to round this to 2 decimal places to get this. Because this is up to 5 and more, I convert it to 3.4 centimeters squared. So that is the area of the major sector. That's the area of the major sector. Now we will look for the area of the triangle. We look for the area of the triangle AOB. The area of the triangle AOB. I'm going to clean this side again. So that is B. Area of triangle AOB. Which is equal to, this area is equal to, so AOB. That's the reason why I still left this thing to be on the board. So we are going to find AOB, the area. But the area is saying that half base, which is line AB, times height, which is OC. That is this line. That is the formula for the area. But we don't know OC, so therefore we have to find that using the Pythagoras theorem. Now we can do that by saying that OC is equal to the root of, we are going to get the root of OB squared, line OB squared minus line CB squared. We are using this side. This is the hypotenuse and this is the opposite. So once I'm grouping it, I group like terms. So initially, it is going to be, let me write it somewhere here, OB squared is equal to OC squared plus CB squared, right? And I group like terms. But I'm grouping it, I'm making OC the subject. I will have this to be equal to CB, that is one coming will be OB squared. Then this becomes negative CB squared. And because I want to get rid of this, I will take a square on both sides. And that's how come we have this. Okay? So that is it. So now we need a substitution. We do a substitution. OB is 7.8 centimeters squared, and we have CB, which is also 4 squared. And this is finally going to be equal to, because of time, I have the answer here, or you can use a calculator to also do that. 44.84 centimeters squared. Take the root of it, we are going to get 6.696 centimeters. Okay, you can use a calculator to do that. And that is where your answer lies. Now that we know OC, we can find the area of triangle ABC. So I continue from this side. So the area of triangle AOB is equal to half of AB, and AB is 8, so 8 centimeters, times OC, which is 6.696 centimeters. And this is finally going to be equal to, you can use the calculator and punch inside to get your answer. So I have half times 8 times 6.696, and your answer is 26.784 centimeters squared. Because of this centimeters, you are going to get centimeters squared, and that is the answer we are looking for. We correct 2 decimal places, so therefore the area is 26.784 centimeters squared. So this value depends on how, or the number of values you have left here. That will determine what this value will be. So you advise to leave it in 4 decimal places before you finally conclude it over here. Now we have found the area of the triangle. Now the last one, that is the C. Very interesting. I was to find the area of the major sector formed by the chord. The area of the major sector formed by the chord. So we are looking for the area from this side to the whole of that. That's what we are looking for. So with that, there are 2 ways. The first one is we already know the area of the triangle and we know the area of the major sector. We can add the 2 of them to get it quickly. So the area of the major sector, let me write it here. The area of the major sector formed by the arc, by the chord, AB is, I'm going to add the area of the major sector, area, so it's equal to area of major sector plus area of triangle AOB. Now, we found the area of the major sector, which was 158.44 centimeters squared. Remember, plus the area of the triangle, which we just found, which is this, 26.78 centimeters squared. This is finally going to be equal to 185.23 centimeters squared to 2 dp, 2 decimal places. So when you add the 2 of them, the area of the triangle and the area of the major sector that we calculated earlier on, you are going to get the area of this major by the chord. That is one of the ways. I'm going to clean this off. The other way is that you can find the area of the minor sector and take it from the entire circle. So when I find the area of the minor sector and subtract it from the circle, I am going to get the area of the remaining part. So we know the area of a triangle, the circle is area of circle is equal to pi r squared. And this is equal to 22/7 times 7.8 centimeters squared. So that is how you can calculate for that, which is 191 centimeters squared. So that's the area of the entire circle. So the area of the minor sector is equal to, so you can use the same formula we use for the area of the major sector, that is the angle here, it is x. You can use x over 360 times pi r squared. And you substitute inside, you are going to get, but remember the angle here was 61.70 over 360 degrees. Now multiply by 22/7 times 7.8 that's correct, and this is going to be 32.77 centimeters squared. So that's the area of the minor sector. Now when you take it from this particular one, that is, you now take 9 minus that 0.77 centimeters squared, you are going to get 185.23. So these two methods you can use to solve the same thing to verify if you are right or you are wrong. So thank you. So this is the end of it, and please, if you have any comment, put it in the comment section. Don't forget to leave a subscribe and a like so that YouTube can promote my content to a lot of audience. Please do me a favor by liking. The things I'm using, I have the microphone and my tripod stand. I'll put the link in the description. You can get them on Amazon, the things I'm using to do this tutorial. Thank you and have a nice time. Bye.